As we begin learning about C, let's take a look at a minimally valid C program. In the Chapter 3 folder of your exercise files, you'll find hello.c. Just copy that and paste it into Working Project and double click on it. And this is a minimal C program. It's actually not the smallest, most minimal possible legal correct C program, but it is the smallest practical example of a correct C program. Let's take a look at all the different components. In the first line here, we have a comment, and you'll notice that this comment is introduced by the double slash. This is actually a syntax that was borrowed from C++ and was added to the C standard with C99. But it's commonly used, and it has the advantage that if you come out to the end of a line and you want to put just a comment to the end of the line, you can do it that way, instead of using the old syntax, which would have been to have a slash and an asterisk, and then another asterisk and a slash at the end of the comment. Now, the advantage of the old style C comments is that you can actually have your comment span multiple lines. So you can have it go on and on and on like that, and just introduce it with the beginning comment marker and have the ending comment marker at the end of it. Each style has its advantages. I tend to like the slash version, slash to the end of the line. It's simple and it's quick, and most of my comments are just one line anyway. The next line is actually a preprocessor directive, and we'll get into the preprocessor in our next chapter, but this one includes a file, and it includes this file in place. And so this file called stdio.h, which is sometimes simply pronounced standard IO, the entire file will be included in the compilation process in this place. And that allows us to have all our function declarations for the standard IO functions from the standard library. Next, we have the declaration of the main function. The main function is reserved in C. All C programs must have a main function. It's where execution begins. So it is required. It is not optional. Correctly, the main function should return an int. And so you see that first word int, that declares the return type for the function. And you notice we have a return statement that says return 0, and that 0 is the int that's being returned by this function. After the word main, you have parentheses, and inside of those parentheses are declarations of variables. These are the variables that will be used for parameters. When parameters are passed this function, they'll be copied into these variables, and those variables become accessible inside the body of the function. Then there's an opening curly brace, and there's a closing curly brace on line 7. Those mark off the beginning and the ending of the block of code that is the body of the function. And inside the body of this function, we have two statements. The first statement is a function call, calling a function called printf. And you know it's a function call because it's got a name and parentheses and something inside of the parentheses. And the next statement is the return statement with the 0. Both of these statements are terminated by a semicolon, and that semicolon is not optional. In C, all statements must be terminated by a semicolon, even if it's the last statement in a block. In a lot of languages, a semicolon can be omitted as the last statement of the block. That makes the semicolon more of a separator than a terminator. In C, it's a terminator, and all statements must be terminated by a semicolon. If I remove this semicolon from the return statement, you'll notice we get a syntax error. It says right there, syntax error. And so that semicolon is required, and it is not optional. So let's go ahead and compile this and run it, and I'll press this run button up there, and you see the printf function displaying the string hello world. That's the argument to the printf function. Now, another thing you need to know about C is that all of this white space is really just there for decoration. It makes the program readable. In other words, I can get rid of these indents, and it'll still run just fine. I can put these curly braces on a separate line, and it runs just fine. In fact, I can get rid of all of the white space, except in a few places where it's required. Obviously, it's required between the return and the 0, because otherwise there'd be no way to know that these are two different tokens. Likewise, between int and main. But every place else, well, we need it between int and argc, but we don't need this one. And we don't even need these. And we don't need that one. And we don't even need that white space there. So this is a perfectly valid C program. I'm going to save that, and we'll compile it and run it, and you see it runs just fine. Of course, this is not very readable. So the reason we have all of these spaces and the indents is to make the code readable. Now, there's different styles of doing this. Some people like to put the curly braces on lines by themselves. Some people like to indent one or both of the curly braces. Whatever style you choose, just be consistent with that style. There's no one right way. Of course, if you work with other people, it's oftentimes useful for everybody to agree on a particular style and to stick to that style. I tend to use the old K&R style because it's the first one that I learned from the original C programming book that came out in the 70s by Kernan and Ritchie, often called K&R. So I tend to use a style like that, which is what you see here, but it's not the best. There is no best. The only thing that matters is that you're consistent and that you use the same style consistently so that you can read your code and so that other people can read your code. Now, because C++ is based on C, its syntax is basically the same. Let's take a look at a C++ version of this program. So I'm going to go ahead and delete this from the working project, and I will run clean. We'll take the hello.cpp, copy that, and paste it into working, and double click. And here we have the hello.cpp version of this. That's in C++, and I'll just run it, and you see it does exactly the same thing. And there are a few distinct differences. You'll notice that the include directive includes something called IOStream, and it does not have a .h at the end. It's traditional for C++ include files to not have the .h. You also see a line called using namespace standard. Namespaces are a concept that is in C++ but not in C, and we'll learn about namespaces later on in the course. But suffice it to know at this point that the objects in the standard library, the C++ standard library, are all in the standard namespace. So this cout is actually in the standard namespace. If I take out that line that says using namespace standard, then I need to declare, you see I get a syntax error there, symbol could not be resolved. Then I need to declare that cout is in that namespace, and I do that like this, std and 2 colons. And that declares that cout is in that standard namespace. And now if I save it and run it, it continues to run fine. I'm just going to click this run in background. So I tend to have the using namespace line towards the beginning of all of my examples in C++ because it makes it easier. I can just type cout instead of std : cout, especially if there's a lot of objects in the code that use the standard namespace. You'll also notice that the text is output with the cout object rather than using printf. And cout is an object, so it's using an operator here. It's actually overloading the left shift operator in order to send text to this output stream. That's become a common thing for input and output streams, and actually the IOStream library does that a lot with the various input and output stream classes. In fact, you can use printf if you like, and I'm just going to put that in here instead. Say printf and call the printf function. Even though in the GCC library, printf is declared in IOStream and it's actually even declared in the standard namespace, it's more common when you're using printf to go ahead and include the stdio.h file or its C++ equivalent. And so C++ equivalents of .h files have a C at the beginning and no H at the end to designate that they're part of the C standard library and not the C++ standard library. And then I no longer need this using namespace, so I can comment that out. I can save this and run it, and you'll notice that we're basically running exactly the same program that we had in the .c file, but we're running it in a .cpp file and compiling it with the C++ compiler. So it is possible, because the entire C language is included in C++, to simply write C programs in a C++ file. Obviously, if you have C++, it's a good idea to make use of its various features, but it's also good to know that your regular C code will run just fine in C++. So let's go ahead and delete this file and clean it up, and project clean. And now we're all clean for the next lesson. So that's the basic syntax of a minimal C and C++ program. We'll get into more of the details later in this chapter.